Hello guys, so I welcome you all on this wonderful platform that is BYJU'S Exam Prep. And guys, today we are going to start the discussion on the theory of machines, first chapter. The name is simple mechanism. And as per the discussion guys, in this session or in this series, now we are going to discuss each and every concept in a great detail. So complete simple mechanism would be taught to you guys, and as we have already previously thought to have the time of 7 p.m. for this, but due to some unavoidable reason, because mathematics is soon also going to be started at the 6 p.m. time, so we would be having the time of this session from tomorrow onwards as 5 p.m. okay, so today we are starting at 6 p.m. from tomorrow the timing would be 5 p.m. because after that you would be having mathematics session. After 2 to 3 days mathematics would also be started. So guys, please tell me, am I properly audible and visible to all of you or not? Yes, am I properly audible and visible to all of you or not? And do like and share the session, subscribe the channel if you have not done yet. So we are starting the session guys. So today the topic we are going to deal with is kinematic link, pair and chain. So guys, these are the topics of discussion today. So let's start moving. So my dear, first of all, this is some detail about me and these are the areas of interest, and now theory of machines are going on for you guys. Then my dear, I would like to tell you about one more thing we are coming with. We are coming with concept capsules for you. Like there are many topics where interviews are also going to ask the question. You are also getting the similar numericals on that concept in the GATE examination, ISRO examination, BARC examination. So for such concepts which are very, very important, we are going to start with the concept capsules, where for mechanical civil every Tuesday and Saturday you would be having a session of 15, 20 or 25 minutes describing about some important and wonderful concept. Ravi Kishore, thanks dear, thanks for that. So let us start guys, and the timing for that session would be 9 a.m. and it would be starting most probably from the next week. So be ready for that. So guys, this is the last announcement for today. From 8th May, on 8th May 12:30 p.m. we are having a session that how to ace GATE 2023 in first attempt. The session would be taken by Ashutosh Saxena sir. So do join this session. He is IIT BHU alumnus, 10 plus years of experience. This session would be helpful for those who want to successfully attempt for the first time in GATE 2023. So guys, now let us start the session without wasting the time. So my dear, the theory of machines, we are going to start with the very first chapter. Okay, that is when we are talking about simple mechanism, this is the complete syllabus of tone and vibrations. So we are starting with the very first chapter. And my dear, when we are talking about the name of the very first chapter, if you see the wonderful name of this chapter, the name is simple mechanism. I told you that I would be teaching you from very, very basics. I would be teaching you from very, very basics. So my dear, just try to understand. When I am saying the name of this chapter is simple mechanism, I would be explaining why the name is given like that. So my dear, first of all, if you see the very first word, the very first word is simple. So my dear, whenever something is coming for the first time in the universe, it is coming in its simplified version. Then we are going for the modification. So my dear, the very first harmonic motion of the word was given the name of simple harmonic motion. The very first type of gear train of the universe was given the name of simple gear train. The very first type of spur gears were given the name of simple spur gears. Similarly, the very first type of mechanism of the universe, of the world, were given the name of simple mechanism. So my dear, when I am saying simple mechanism, it means we are going to discuss about the very first type of mechanism which came into picture. Rajat Mishra, good evening dear. So guys, we are going to deal with those mechanisms which are the first time is the firstly came mechanism we are going to talk about. And my dear, when we are talking about mechanism, they are going to be useful in the machines. In the first session of theory of machines, when I was having general discussion, I told you why we study theory of machines, because discussion of theory of machines helps us in the production, in the machines, because all the machines are working on some of the mechanisms. So my dear, when machines are working on some of the mechanisms, and the dealing of mechanisms we are going to do in this subject. So we will see how that first kind of mechanism came into picture, what are its various orientations, what are its various configurations. So we will see each and everything in a great detail. Setupati, yes, very good. So guys, now we are going to start for the very first term. So in this very first term, the very first term is kinematic link or element. So when we are saying kinematic link or element, as the name suggests element, it is going to be a part of some mechanism or machine. So look at it, what I am saying. I said the very first point, it is going to be a part of mechanism. I said it is going to be a part of mechanism or machine. So it is going to be any part of a mechanism or a machine. And when we are saying that this is a part of a mechanism or machine, so my dear, it can be fixed or moving. I said the second point that it can be fixed or moving. It can be fixed or moving. It can be fixed or moving. But my dear, it must have a relative motion. Don't worry, I would be explaining each and every term. First of all, I am just writing the point. It must have a relative motion. And my dear, this is the definition, including that it is a part of a mechanism or a machine which may be fixed or moving but shall have relative motion with respect to some other part. So my dear, that thing can be said as a kinematic link or element. Crank, connecting rod, slider, cylinder in an IC engine, all are known to be a link. In a lathe machine, chuck is rotating, it is a link. My dear, lathe bed is fixed, it is a link. So my dear, when I am saying that it should be a part of mechanism or machine, it's fine. But students are getting confused in this point that, sir, one side you are saying it can be fixed or moving. When you are saying fixed, it means lathe bed can also be a kinematic link. Yes, it is. When you are saying moving, it means chuck which is rotating in lathe machine can also be a link. Yes, it is. Then why you are saying relative motion is must? So my dear, to understand this point, you must be clear about absolute motion and relative motion. So let us say, my dear, there is some person A, okay, and there is some person B, and there is some person C. So my dear, this is A, this is B, this is C. C is at rest. And my dear, when C is at rest, A starts moving with 10 meter per second. And my dear, B starts moving with 5 meter per second. So my dear, these are the velocities of A and B according to the C. You know, as C is at rest, whatever C would be saying about A and B, these are said to be the absolute velocities. So my dear, absolute velocities indicates the absolute motion. So if you see, according to you, A is in motion, B is in motion, but C is at rest. This is what you are thinking of. As absolutely, yes, you are correct. A motion में है, B motion में है, C rest पर है. Yes, good evening bhai Mahesh, welcome to this session dear. So my dear, if you see this, you can say A and B are in motion, C is at rest. But these are the absolute thing you can say. But my dear, as I say, there are things which are said to be relative motions. If B would be looking at A, my dear, when B would be looking at A, B is moving with 5 meter, A is moving with 10 meter. If I ask you what would be the velocity of A with respect to B, that is said to be the relative motion. Anybody, Setupati, Rajat, Ravi, can you tell me what is the velocity of A with respect to B? When B would be looking at A, what would be the feelings of B about A? In terms of motion, I am talking about, guys. Don't take it feeling in the other sense. So when, my dear, B would be looking at A, you know that the nature of human being, we only can see the things relative to us. So if B is moving with 5 meter per second, A is moving with 10 meter per second, according to B, A would be moving with 5 meters per second. Very good, Bhavya. So velocity of A with respect to B is nothing but 5 meter per second. And my dear, what is the procedure to do that? If you want to see velocity of A with respect to B, just give the velocity of B in opposite sense to A. B is moving 5 meter in this way, give that opposite to A. So A is having 10 here, 5 here, net it would be left with 5 meter per second. This is the way to check the relative velocity. Similarly, when B would be looking at C according to B, if you want to write down the velocity of C according to B, then my dear, it would be giving its own velocity opposite to the C. So according to B, velocity of C is going to be minus 5 meter per second, because we have chosen this direction positive, this would be negative. So according to B, C is not at rest, C is in motion. So my dear, that's what I wanted to say, that for a kinematic link, relative motion is required, absolute motion is not required. So if you want to say anything, a link, it must have relative motion with respect to others. If you see absolutely, C was at rest, but relatively, C is in motion. In the same way, my dear, if you are talking about a lathe machine, whenever you enter into the machine shop, you will never see lathe machine moving. Lathe machines per chuck would be running, but lathe machine bed would be at rest. But my dear, that bed is also a link, because it seems to be at rest when you are looking it from earth. If you would be looking at that lathe bed while sitting on the chuck, you will feel lathe bed is also moving. That is called as relative motion. So my dear, the point is relative motion should be there, absolute motion may or may not be there. Is it clear? So my dear, that is something known as kinematic link. Now my dear, a very important statement I would like to give here for kinematic link. My dear, a link may or may not be a rigid body, may or may not be a rigid body, but it must be a resistant body. So guys, our target of this series is to make your 2 marks secure. So it should be a resistant body. That is what the definition of kinematic link is. So my dear, when we are saying it may or may not be rigid, but it must be a resistant body, for that we need to understand the meaning of rigid body. So my dear, when we are talking about rigid, a body is said to be rigid if deformation of the body is 0 when we are applying the forces onto the body. Like my dear, if we are having a spring and we are applying some force onto this spring like F, and K is the stiffness, you can write F is equals to K into X. Here X is the displacement of spring or deformation of spring. So my dear, if you keep K to be F by X, if you say that this spring is rigid, so my dear, this spring will become rigid, for that X should be 0. Putting X 0, K would become infinite. So when we are saying body is rigid, it means its stiffness is infinite. So we have already said that a link may or may not be rigid. जरूरी नहीं है link का rigid होना, वो rigid हो भी सकता है, नहीं भी हो सकता, but it must be a resistant body. So my dear, if you want to understand the meaning of resistant, for that I am going to take an example where I would be taking 3 students out of your class only. Let us say we have many students in the class. So let us say we are having 3 students. Let us say we are having Rajat, we are having Bhavya, okay, Rajat, Bhavya, and third let us say Setupati. So these are the 3 students I am taking. Let us say these are 3 persons which are very good friends of each other. And my dear, they are sitting on a bench. I take this example for your better understanding. They are sitting on a bench. They are 3 very good friends, Rajat, Bhavya and Setupati. So my dear, they were sitting on a bench normally, and after some time Rajat got angry. He remembered some incident in his mind and he got angry. And when he got angry, he just slapped the other person, Bhavya. So Rajat slapped Bhavya. When Rajat slapped Bhavya, Bhavya first of all thought, why he slapped me? Then he thought, okay, he is my best friend, he can slap me. He left Rajat, okay, no issue, it's fine. So Bhavya did not react it. It's fine, it was a case because of friendship, he did not respond to that. Let us say after 10-15 minutes, Rajat once again got angry and he once again slapped Bhavya. Once again Bhavya seen that what he is doing, but still he thought, okay, his friend, he didn't respond it again. This happened a number of times. Rajat was slapping Bhavya, Bhavya was not responding to him. So my dear, in this case, Bhavya is alive. He is alive, but he is not giving a feeling that he is alive. So we would be thinking that whether Bhavya is alive or not. because he's not reacting, he's not responding. So my dear, this kind of bodies are said to be non-resistant bodies, which are not giving any kind of resistance. So my dear, such kind of things if present, we will not call such kind of things as a link. So Bhavya, for this definition, we will say Bhavya is not acting like a link. So my dear, for to be a link, body should be a resistant body. Maybe what could be the second case, when Rajat is going to slap Bhavya, then my dear Bhavya look at Rajat and he found Rajat is having very good body and Bhavya say I cannot compete with him. Then my dear, he may do some kind of reaction at least, either by giving some abuse or by transferring this slap to Setupati if he would be doing any kind of resistance, or by asking for help nearby peoples. Whatever he could do, if he would be trying for that, we would be saying to be a resistant body. So the point is, resistance is required, rigidity is not required for any link. If you got this point, it's fine. If you did not, don't worry. Now I am going to explain this in a great detail in an example. Okay. So first of all, let us see what is the example. I am taking a normal simple 4-bar mechanism, and let us say this is a simple 4-bar mechanism. This is O, this is A, this is B, and this is C. My dear, I am teaching you from very basics as per your request, because this is a difficult subject. So we are going like that. So my dear, let us say you have given the motion to this link with an angular velocity of omega. When you have given this motion, my dear, what happened is, this AB link, it was not a rigid body, so it got deformed like this. When it is going to get deformed, there would be no motion transfer is going to happen. Okay. Yes, thanks Bhavya, and thanks for that, you didn't mind that. So my dear, then we once again have applied the forces and given motion to the link OA. When we have given this motion to the OA, once again what happened, that once again AB is getting deformed, but is not transferring the motion to BC. So my dear, when again and again you are trying to move this, but the motion is not happening, one time would be coming when this link is going to fracture, but it would not be able to transfer the motion to BC. My dear, in such case, we would be calling this link, it is not rigid. If somebody asks, is it rigid? We will say no, because deformation is happening. And somebody if asks that, is it resistant? So my dear, we will say no, it is not resistant, because it is not resisting as well. So my dear, if we ask, is it a link? You will say no, it is not a kinematic link, because for any link, it must be a resistant body at least. So my dear, we are moving to the second condition now. So my dear, the second condition could be like this. We have this link like this. This time what happened is, you have applied the force like this, and this OABC, this time AB was not deformed, it directly transferred the motion to BC. It is similar to the case that Bhavya have seen that Rajat is somehow you can say stronger than Bhavya, so Bhavya was not wanted to take risk. He finds Setupati to be lesser, or you can say weaker than him, and he transferred the slap to the Setupati. When Setupati asked, why you slapped me? He said, because Rajat slapped me, so I just transferred that slap. So my dear, that kind of motion if going to happen, for this case you would be saying AB is rigid link. Yes, it is, because it is not deforming at all. My dear, is AB resistant? Yes, it is, because it is transferring the motion to the other link. If somebody asks, yes, AB is a kinematic link, you will say yes, AB is a kinematic link. So my dear, this is the wonderful thing you can see. Now I am coming to the third and the last case, which would be removing all the confusions from your mind. And guys, please tell me, are you able to understand or not the explanation I am giving to you? It is very easy. This is my guarantee. If you would be joining live for next 5 days with me, your 2 marks are going to be secured, and you would be remembering this series forever, because these 2 marks are coming every year. Every year question is there from simple mechanisms. Then my dear, if you see the third and the last case, this time you have given this motion. This link was getting deformed, so motion is not transferred for the first time. Then you once again have given the motion. This time motion got transferred. So here the motion is getting transferred after some deformation. So as deformation is happening in AB link, this is not at all a rigid link. But this time, yes, it is a resistant body, because after some deformation, it is transferring the motion. So yes, you would be calling it as a kinematic link. So my dear, for anybody to be a kinematic link, it should be a resistant body. Very good, Rajat. So my dear, that's what I wanted to say, that for kinematic link, it must be a resistant body. Rigidity is not at all required. It could be rigid, could not be rigid. Okay. So my dear, then you see the definition, whatever I have written once again is written here. So whatever the PDF you would be getting from every class, you need not to make any kind of notes for that. Everything is written. That every part of a machine which is having some relative motion with respect to the other part is known as kinematic link or element. It is necessary for the link to be resistant body so that it is capable of transmitting the power one element to the other element. So my dear, this is what is the definition of kinematic link or element. You can see for one definition I explained that much to you. So how the classes are going to be, this is what, my dear, the way we are going to follow in the classrooms. So you are getting the similar thing which you are getting in the paid classrooms. Rigid and non-resistant. Dear, actually when we are talking about resistant is the first thing. Rigidity may or may not be. So there is no combination like that. If some body is resistant, then my dear, obviously it may be rigid, may be non-rigid. So my dear, now we have explained about the kinematic link. Now I would be asking you about an example, and that is my interview question also, and it have been asked in many interviews. Okay. So my dear, that question is, we are going to join actually. There are two discs, and or you can say there are two cylindrical discs, and these two cylindrical discs seems to be like pulleys, and they are attached with a rubber band. So this is rubber band. And my dear, there is a question asked in the interviews that if we are going to say this is one disc, this is another disc, so rubber band will be acting like a link or not? Will rubber band be a kinematic link or not? So my dear, I am giving you the explanation first, then you would be answering me. That if you are going to rotate this cylindrical disc, and after rotating this cylindrical disc, if this disc also starts rotating, then my dear, you will call rubber band is a link. But if on giving rotation to this is not at all rotating, and my dear, rubber band is going to get fractured, then my dear, you will call rubber band is not a kinematic link. So my question to you is rubber band a kinematic link or not? That is what you need to answer. So guys, one more thing I would like to ask, if from tomorrow we keep the time of the class at 5 p.m, will it be okay for all of you or not? Because timing we are going to change, because from 6 p.m, after 2-3 days mathematics would be starting. So can we shift the timing to 5 p.m? Will it be comfortable for you? Please tell me that. Yes. And also answer to this question. This is a very, very important interview question, guys. And guys, we would be going in a full detailed version. The level of question I would be discussing for this chapter, you will see, you have never seen that level. And you would be prepared for each and everything from the simple mechanism. And if you would give good response to this, I would be continuing from second chapter onward, because I want to teach you completely only if you are interested. Okay? Fine. So what about this? Is this rubber band a kinematic link or not? Is it a kinematic link or not? What do you say? Yes. Okay, Mahesh is saying yes. Rajat is also saying yes. Okay. So my dear, will it depend on the very good Bhavya? I feel you have attended this session before, then only you are able to answer it. Is it correct or not? Yes. So that's fine. That's fine. Okay. No issue in that. So my dear, actually I just mentioned this point. Yes, very good Rajat. Okay, fine. I mentioned this point so that those who have given wrong answer, should be knowing that. Yes, this is because if you don't know about that, you cannot give the right answer. Okay, so very good, guys. So all of you are majority saying that yes, it is a kinematic link. So my dear, now I am going to explain this. Yes, Bhavya, it's fine, great. So my dear, now I am going to explain this. First of all, whenever this question is coming to you, that whether rubber band is acting like a kinematic link or not, if you see in the comment section, nearly all the students have said yes. I feel Maliha have said no, it's fine. So still it is a 80-20 ratio, I will say. So my dear, when we are talking about rubber band, whether it is acting like a link or not, that would be depending on some of the factor. If I assume these cylindrical disc to be very, very small cylindrical disc, like do you remember when we were having audio cassettes which were played using the tape recorder, when you were putting the audio cassette into the tape recorder, playing the play button, the input link was rotating, and because of that there was a reel which was trying to rotate the output link, and in that way both are rotating like this, and we were capable of listening the song. So my dear, if these are those cylindrical discs, then my dear, rubber band can very easily rotate this link whenever this link would be rotated. But just imagine the case if these cylindrical discs are not those small discs, but they are road rollers. Do you know about road rollers? Have you seen the road rollers? They are very, very big, very, very high inertia, very, very hard in nature. They are made up of manganese steel, Hadfield steel, where 12% manganese is there. They are very, very hard. So my dear, then do you feel that if this rubber band would be attached to the road roller, will it be capable of moving that road roller? Do you feel like that? Yes, Rajat, Maliha, Anji. Yes, do you feel like that? That rubber band would be capable of transferring the motion between two road rollers, which are very, very big rollers. You know, road rollers are very, very big. So do you feel if I would be attaching a rubber band to that, rubber band would be capable of rotating it? No, it's not. Rubber band is going to fracture in that case, my dear. So rubber band would not be able to transfer the motion if you would be having road roller. So my dear, this rubber band would be acting like a link only if inertia of the disc is very, very low. So if the inertia of the disc is high, then my dear, this rubber band would not be acting like a link. So whether this rubber band would be acting like a link or not would be depending on the inertia of the cylindrical disc. This is the answer to this question. This is a very famous question for engineering services as well as ISRO, DRDO, GATE, IITs, MTech. It have been asked many times. Is it clear? So very good Rajat, very good Anji. So my dear, this is something about rubber band acting like a link or not. Now my dear, let us move to the next part. We have seen what is a kinematic link. Now my dear, we are moving to the second part, that is nothing but the types of link. So my dear, what are the various types of link? So my dear, the very first type of links in front of us are rigid link. So my dear, if we have a link for which deformations are either equals to 0 or they are tending to 0, means if we have negligible deformation, obviously negligible deformation on application of forces. You might be thinking, sir, why you are assuming that every time forces would be there? Because my dear, we are studying theory of machine. Theory of machine means mechanism. Mechanism means motion. None of the motion is possible without force. So forces are always present. So if I apply the force onto this link and this link is having either zero deformation or negligible deformation, then I would be calling such a link as rigid link. So my dear, the example for rigid link is cylinder. The example for rigid link is, yes, in IC engine cylinder is there. In IC engine piston is there. In IC engine crank is there. In IC engine connecting rod is there. So my dear, whatever these links are, they all are solid links, rigid links, and my dear, in these links the deformation is going to be negligible. So if you are going to apply the forces, you will find out negligible deformations. So that's why all of them are acting like a rigid link, my dear. Then, my dear, the second case is flexible link. So, my dear, okay, some question is coming, I feel. Sir, I cleared GATE 2021 but not with good rank. I am in ISC as a project assistant. Sir, can I get any concession for full-time subscription? Okay, Praveen. Okay, Praveen, fine. So, dear, you can connect with me on that. I would be trying for that. I would try to connect you with the team, and definitely they will consider your position and all. But it would be great if you have given the scholarship test on 1st May. But still, Parveen, I will say that you can share your contact on my Telegram channel, that is Mechanical by Dheeraj Sardana. Okay, or I am writing my email ID here. You can mail it to me. So I would be forwarding your query. Okay, you can also share your contact here if you don't have any issue in that. So this is my email ID, dheeraj.sardana@gradeup.com. You can send me the same mail onto that. I would be, and share your contact there. I would be forwarding your contact to the team. They would be contacting you then. Okay. So my dear, next is the flexible link. So my dear, if on the application of forces, deformations are there, but those deformations are in, you can say, in permissible ranges. So my dear, if deformations are not zero, they are not tending to zero, but they are in permissible ranges. Permissible ranges. So my dear, in that case, we call it as a flexible link. The example of the flexible link is what? You will call it as rope drive, belt drive. So my dear, rope drive, belt drive, they all are example of the flexible link. Because whenever you are going to connect two pulleys with a belt, you know that when two pulleys are connected with the belt, one side is going to be tight side, other side is going to be slack side. So when you start rotating it, first of all, the slack side is becoming tight, and then only the motion start transmitting. So first of all, my dear, the belt would be coming tight, and then only the motion would be starting. So before the motion gets transferred, some deformation is going to be there, and because of that deformation, we call it as flexible link. My dear, you can see when you are going to open your bonnet of the car, you will see the belt drives present, which are joining engine with the cooling system. They are flexible link. Then my dear, fluid link we are talking about. So my dear, sometimes fluid is also helping us in transferring the motion. So my dear, for such cases, we would be calling fluid is also acting like a link. So if you want to see the example of the fluid to be acting like a link, this is one of the example. This is the type of mechanism you have seen for the very first time in the 6th and 9th class, you can say, where you were feeling that we are going to give a very small amount of force here. Very small amount of force would be applied here, and you are going to lift a car from this. So these types of devices which are related to fluid, if you would be applying because of Pascal law, my dear, this fluid, which is a pressurized fluid, would be capable of transferring the motion, because on applying the pressure here, this car would be lifted. So all the application like hydraulic brake, like hydraulic jack, like hydraulic ram, like hydraulic press, hydraulic intensifier, all the applications where you are using fluid, as they are said to be fluid acting as a link. So my dear, then only the motion is going to transfer. This is possible only because of the property pressure. So my dear, Pascal have given the Pascal law related to this. So my dear, I will say all the devices with the name hydraulic, like hydraulic press, hydraulic ram, hydraulic intensifier, hydraulic jack, hydraulic brake. So my dear, for all these cases, you would be having that fluid is acting like a link, because you are capable of giving motion. So this is input, this is output. So where motion is there, it is a mechanism, you can say. So motion is going to be transferred with the help of this fluid. So my dear, this fluid is a liquid minded. With the gas, it may not be possible as it is. Okay, because gases are compressible, you know that. Very good, Rajat, very good. But my dear, hydraulic turbines are not covered in the same category. In turbines, the working is different. So you will not be covering hydraulic turbine into the same category. Is it fine for everyone? So guys, just like and share the session. You can see I am going in much detail for you guys. Now my dear, yes, I would also like to inform you that only 2 days class is theoretical in this subject. From tomorrow onwards, class would be too much numerical. So only first class is theoretical because these concepts are going to be used from tomorrow's classes. So except 2 days class, every class would be having numericals. So today's class is theory only. From tomorrow, we would be having a number of numericals as well. Okay. So now we are talking about the types of relative motion. I told you anything can be said to be a link only if we can call anything to be a link only for the special case when there is a relative motion. If there is no relative motion between two links, they would not be called as two different links. Okay. So for anything to be a link, there should be a relative motion. So my dear, what are the types of relative motions? You can see one is completely constrained motion, other is successfully constrained motion, third is incompletely constrained motion. You can also call this motion as unconstrained. You can also call this motion as unconstrained. So my dear, when we are talking about completely constrained, successfully constrained and unconstrained motion, then first of all you must understand the meaning of constraint. There is a word used, constraint. So my dear, constraint का meaning होता है restricted. This is said to be restricted. So my dear, actually if somebody can have n types of motion, and if we restrict n-1 type of motion, then it would be able to do only one kind of motion, that is said to be constrained motion. It is like when you entered into the 11th class and you have made the decision to go for science, physics, chemistry, mathematics, and you decided that you would be going for IIT. At that time your parents have restricted your motions. When you started to go for science, my dear, your parents says, now you have taken science, beta, be serious. From now onward you will not be watching TV for more than 30 minutes. From now onward every Sunday cricket match you will not be going. From now onward you have to study at least 8 to 10 hours a day. From now onwards you will not be going for any extracurricular activities. From now onwards you will not be going to any marriage. From now onward you will not be enjoying festival much. For Deepavali there is 10-day holidays, for other, for you it is only going to be for 1 day. From now onward you would be going to coaching from this to this time. So my dear, your motions were restricted at that time to constrain your motion to IIT. So that is said to be constrained or restricted motion. So if a body can have nth type of motion, we will be restricting all of them except one what we want it to do. That is said to be the meaning of constraint. So my dear, this constraint is becoming with the help of restrictions. Now these restrictions can be made from the system itself or can be made forcefully. Like the students who are serious for IIT, their parents need not to say every day the same thing. They would be just saying once, beta, be serious, and they automatically would not be going to here and there. Whenever they will get time, they will go to library and they will study. They will leave TV, they will leave social media. They will just be concentrating on the study by their own. It is said to be completely constrained. When they are coming from inside, we are not doing anything for that. From inside they don't want to do anything. That is said to be the system configuration is restricting all the motion. We need not to do anything else. So their parents need not to make extra effort to make their motion constrained. That is something completely constrained. There were other students who were not serious by themselves. Their parents every 10 day, 15 day were giving the dose to them. Beta pad le, I am giving that much amount to that. Have you seen the movie 3 Idiots? At that time, when they go for the scene, that we could afford only one TV and that TV we have made into his room. Remember that example or not? So my dear, that kind of sacrifice when parents are doing and they are explaining that after every 10-15 days, that is said to be forcefully they are trying to make your motion constrained. Majority of us are lying in that category only. So let us understand it once again. So when I am saying first of all completely constrained motion. So my dear, when completely constrained motion means if only one type of system is possible from the system configuration. So we need not to restrict any motion because other motions are automatically restricted. Like you have a road and this road is of rectangular cross section. Let us say like this. And this road is going to be in a hole, and that hole is also of rectangular section. So this hole is also going to be of rectangular cross section. So in this hole, this shaft can only reciprocate. This cannot rotate. A rectangle cannot rotate into a rectangle. A rectangle can only reciprocate inside a rectangle. So my dear, by default, there is no other motion possible. So this motion is automatically constrained. We need not to make it constrained. हमें इसको constraint बनाने की जरूरत नहीं है. ये वो students हैं को पढ़ाई के सिवा कुछ आता ही नहीं, और जब उनको पढ़ाई के सिवा कुछ आता ही नहीं तो माय डियर हमें उन्हें बाकी चीजों के लिए रोकने की जरूरत ही नहीं है. वो अपने आप पढ़ाई ही करेंगे जब भी समय मिलेगा. So that is the example of completely constrained motion. So the example for this is, you can say it is a square shaft in a square hole. Square shaft in a square hole. This is the example, my dear. So my dear, this is completely constrained motion. Now the second example is, my dear, if you have a circular shaft, and my dear, on this circular shaft you are placing the circular collar. Like my dear, we are having a shaft like this, and on this I am going to weld a plate like this. So this plate is said to be collar. So I would be just welding such kind of plate on this shaft. So that is shown like this. This is collar. This is collar 1. I am placing a collar 2 here. So my dear, this is collar 1. This is collar 2. And this is the circular hole. In this circular hole, you are putting this circular shaft. So my dear, circular shaft could reciprocate as well as rotate. But these collar will not allow the shaft to reciprocate because these collars are welded like this on the shaft. If they are welded like this and shaft is inside the hole, they cannot have this type of motion because shaft cannot go like this because they are welded on this. So my dear, in such cases, this shaft cannot reciprocate. Shaft can only rotate. So my dear, only rotation is possible. Reciprocation is not possible. This is also an example of completely constrained motion. So I would be saying shaft with collars. Shaft with collars. Some of you might be thinking that, sir, this time collars are making the motion restricted. So why it is not forcefully? Why it is not successfully? Because my dear, those collars are welded to the shaft. So anything if it is welded to the shaft, my dear, it is going to be the part of the shaft. Shaft and collar are not two different things because they cannot have two relative motions. Like if my hand, you can see this is made up of 3 parts, 1, 2 and 3. This part can have relative motion with respect to other 2. This can have relative motion with respect to this. So that's why this is single link, second link, third link. If you have rod in this hand cannot have this type of motion. Then I will be saying this and this to be one link only. Similarly, if shaft and collar cannot have relative motion, shaft and collar are the same only. They are not two bodies in theory of machines. Is it clear, guys? So guys, I could go very fastly also on these topics, but when I am going in that much detail, that is only going to give you the clear idea about everything, and that's what we are doing in this series. Next is, my dear, successfully constrained motion. Now my dear, when we have successfully constrained, so this word successfully is showing some kind of external force. So successfully means when we are going to make the motion constrained, make the motion restricted with the help of some external forces. So this time we would be taking the help of external things to make the motion constrained. So the very first example is this. If you see, this is cylinder, this is cylinder, this is piston. You know, cylinder is also circular in cross section, piston is also circular in cross section. So this piston can rotate inside the cylinder. Piston can reciprocate inside the cylinder. But my dear, when you are going to attach the connecting rod to this, now my dear, because of connecting rod, the piston cannot rotate. Piston now can only reciprocate, because piston would be applying the forces but no torque to rotate. So my dear, that is why when you are keeping the connecting rod with the force, this can only translate but cannot rotate. But this is possible only because of the presence of another link, that is connecting rod. So my dear, that's why it is said to be the example of forcefully or successfully constrained. Let us take some simple example. In your childhood, you was having fear from the injection. So injection, there is a circular tube, there is a shaft, and doctor can do two type of motion with the shaft. He can rotate it like this, he can reciprocate it like this. So because inside fluid he want to inject, he was not doing this type of motion. He was doing only this type of motion. So that's why it is successfully constrained, because possibility was there to do two motion, but we were concentratingly doing only one. So that's why it is successfully or forcefully constrained. Means system configuration was allowing the motion, but we were not allowing to do that. Means you were having a mind to play cricket, to watch TV and all, but your parents were not allowing that by external force. So successfully constrained. Okay. So my dear, now many of you would also be thinking, sir, why we want constrained motion? Okay, let us say it is completely or successfully, but why we want constrained motion? Because my dear, I taught you that we are making the mechanism for the machine's purpose. So when you are making the mechanism for machines, and my dear, in machine, let us say if you have this as a workpiece and you want to do turning operation onto that, you have this as a single point cutting tool or any cutting tool with the help of which you are going to perform the turning operation. So you would be giving this motion to the tool for the turning operation. If by chance you will give this motion, then turning operation will not happen. If you give this motion, turning operation will not happen. So my dear, only for this direction, this motion can happen. So that's why in manufacturing, we want constrained motion. We want motion in a particular direction only. If that motion is not in this particular direction, but in other, the operation will not happen. It will become useless. So that's why in production, we want constrained motion. Is it clear, guys? Are you getting it or not? So my dear, this is a footstep bearing. This is a shaft present in a hollow bearing. So this time, this shaft can reciprocate, it can rotate also. But by this force, we are stopping the reciprocation. So now only rotation is possible. So this is once again the example of successfully constrained motion. And my dear, if by chance motion is not becoming constrained, neither with the configuration nor with the external forces, such motions are said to be unconstrained motion, and we never want unconstrained motion in the production. That's why we are generally working on constrained motions only. I feel everybody would be getting it. Just write something in the comment section that I am going that much detail. Is it useful for you or not? Because I could complete this in 15 minutes also, but I wanted to give you the complete feeling so that you can understand everything about what is a link, what is a pair. Then only you will get the complete feel of the topic. Yes, everybody, please tell me. Rajat, Praveen, Bhavya, Anji. Yes. So my dear, we have completed first heading, that is kinematic link. Now we are starting the second heading, kinematic pair. Okay, I would also like to inform you, just join my Telegram channel Mechanical by Dheeraj Sardana. There you will get this PDF of the today's session. You will get handwritten notes of theory of machines. So you need not to make notes. And from tomorrow onwards, you are going to get daily assignments. Because this is my promise, I would be doing this chapter for you in a great detail, so that you must be in a position to do every question from the topic. So with this topic, we would be completing today's session. Chain we would be teaching, we would be studying tomorrow. So when we are talking about the kinematic pair, I feel everybody understand about the pair. When two things are connected together, it is said to be a joint or a pair. So when any two links are connected together, it is either said to be a pair or said to be a joint. अरे अभी अकेले घूम रहे हो, गर्लफ्रेंड बन गई, पेयर हो गया. सिर्फ गर्लफ्रेंड नहीं, लोगों की सोच वहीं जाती है. If even you have any other relation with your parents, that is also making a pair. Every motion is making a pair. So my dear, pair means when two bodies are connected together. So when two or more links are connecting together, they are said to be a pair. But every pair is not a kinematic pair. So my dear, if we have two or more links connected, it is said to be pair or joint. And my dear, a pair will become kinematic pair. A pair will become kinematic pair if relative motion between the link is a constrained motion. So if the relative motion between the links is a constrained motion, we would be calling a pair as a kinematic pair. So my dear, this is how we define kinematic pair. So my dear, from obviously every kinematic pair would be coming in the category of pair. But my dear, every pair may not be a kinematic one. So I will say, if this is a set of pairs, so out of this, let us say some of the pairs are going to be kinematic pair. So every kinematic pair is a pair, but every pair is not a kinematic. Matlab may or may not be. Okay. So this is the definition of kinematic pair. Now my dear, this is the definition written. As I already told, no need to write. Any connection between two links is always a joint or a pair. But this pair will be a kinematic when the relative motion is a constrained motion. It may be completely constrained, it may be successfully constrained. Okay, both types of constraints are okay. So now we are going to see the classification of kinematic pair. So my dear, classification when we are talking about, the very first type of classification is based upon the relative motion. So when we are talking about based upon the relative motion, the very first type of pair is turning pair. If you want to see the example of turning pair in our body, it is there. This link and this link about this point are having this kind of relative motion. So if you see this relative motion, this is a kind of circular motion. So if relative motion is circular, or you can say pure rotation, then my dear, this kind of pair is said to be the turning pair. So any two links are joined with a pin. If you take this and join them with a pin, that is an example of turning pair. That is an example of turning pair. Okay. The same pair is there in our body like this. The same pair is there between crank and connecting rod. If you have a cylinder, this is a piston. Then with this piston, connecting rod is making turning pair. This is also turning pair. This connecting rod is making with crank a turning pair. This crank with the crankshaft is making a turning pair. So all these are the example of turning pair. Okay. So all these are the examples of turning pair. So my dear, for example, this is a turning pair. This is a turning pair. This is a turning pair. So they are also given the name of revolute pair or pin joint. Okay. So revolute pair, pin joint or rotary joint. Rotary joint is also a name used. Rotary joint. All these are the names. Ministry of Railway. Dear, what I have shared opposite is no problem. If you are talking about this and this motion I am saying pure turning. Okay. So this is said to be turning pair. If you are talking about more than this motion, that if you are talking about this is a spherical pair, because this is 1D rotation, 2D rotation and 3D rotation. Between this and this is a spherical pair. Between this and this is a turning pair. Is it clear? Ministry of Railways. नाम बहुत अच्छा रखा है आपने, Ministry of Railways. Next is sliding pair or prismatic pair. So my dear, when you have a cylinder and a piston, then the motion between these two is pure translation or sliding. So this is the example of prismatic pair. So if relative motion is pure translation, if relative motion is pure translation, we call it as sliding pair. So guys, now the time is over for this session. So in tomorrow's session, I would be teaching you about pure rolling motion. I know majority of the students are not having clarity over pure rolling motion. So tomorrow we would be starting with the third type of pair, that is rolling pair, where I will teach you about the pure rolling motion. Then after completing pair, we will go to kinematic chain, and from chain we will go to mechanism. From mechanism we will go to degree of freedom. And tomorrow's class is going to give you one question, because from the first chapter only 3 topics are there from where questions are coming: degree of freedom, crank and slotted lever mechanism, and third one is Gradeup law. So only these are 3 topics from where questions are coming. Out of 3, 1 we are going to complete tomorrow. So tomorrow's class timing is 5 p.m. I want all of you to present from tomorrow at 5 p.m. and this is my guarantee. Just attend this one series, go for all the previous year's GATE question. You would be requesting for the second series, and once you will do that, I'm ready for the second chapter also. I want to teach you complete tome like that, but for that you need to give response for this first chapter. So goodbye guys for this session. Thanks for joining, and do join the channel Mechanical by Dheeraj Sardana to get the PDF of this session, to get the handwritten notes, to get the assignment from tomorrow. Goodbye guys. Goodbye.